conversion of a voltmeter, a galvanometer into a voltmeter. Now a voltmeter is an instrument which is used to measure the potential difference across the two ends of a circuit or circuit element, right? Let us say this is a branch of a circuit and you have to measure the potential difference between these 2 points. To measure the potential difference between these points, you have to apply, or a voltmeter can be used. So voltmeter is always connected in parallel to the circuit, and since it is connected in parallel, so it must have high resistance. You have to connect in parallel, right, to this. Then if this is voltmeter, then if this voltmeter has low resistance, then the current, maximum current will pass through this, not through this. Then potential difference across these 2 points will decrease, because current decreases, so potential difference also decreases. So this voltmeter must have high resistance so that minimum current can pass through the galvanometer or the voltmeter. The maximum current remains, or the current remains same in the branch of that circuit, so that potential difference remains unchanged, right? Now already we have told that, or we can understand that it should have, or it must have, a high resistance. So actually the resistance of an ideal voltmeter is infinite. For accurate measure of the potential difference, it is essential that the current between the 2 points, current between the 2 points of the conductor or the circuit should remain the same after connecting the measuring device, that is the voltmeter, across the 2 points. A galvanometer can be converted into a voltmeter by connecting a large resistance in series to the galvanometer. Now see here, let us say this is our galvanometer with resistance G. Now if we connect a high resistance R in series to the galvanometer, then total resistance of the device, this device is called a voltmeter, and R effective, that is the effective resistance of the voltmeter, is G plus R, which is near equal to R, and we have also know that R is a very high resistance. So the R effective, that is the effective resistance of the voltmeter, is very high. Now if this is connected across these 2 points, then the effective resistance that is connected across the 2 points, that is parallel to the point, is very high. So current will be minimum. That's why the current remains unchanged through the circuit, and so the potential difference. Now let G is the resistance of the galvanometer, and Ig is the maximum current which can flow through the galvanometer. As we have told that it has an rating, that is beyond the current Ig, it can damage or it can burn. So maximum current can flow Ig, and which shows the maximum deflection. Therefore Ig into G plus R is the voltage difference across the voltmeter, and that is the potential difference across the 2 points of the circuit. And therefore you can say G plus R is equal to V by Ig, or R is equal to V by Ig minus G. Now to measure a potential, the maximum potential difference V, you have to connect a resistance R which is equal to V by Ig minus G in series to the galvanometer. Right? This is the required value of resistance which must be connected in series to the galvanometer to convert it into a voltmeter of the range 0 to 3 volt.